Dear friends, Maths Aspirants is an informal community of mathematics students, research scholars, and faculty members all over India, initiated by myself in 2017. We used to organize online problem solving sessions, online test series, and national webinars on different areas. Today, we have a problem solving session on first order ordinary differential equations by Miss Kajal Sachdeva from Haryana. Miss Kajal has been associating with Maths Aspirants for several years and I am very happy to introduce her. She studied MSc Mathematics from Maharshi Dayananda University, Rohtak, Haryana, and she qualified CSER NET, JRF and GATE examinations. She is currently pursuing PhD at Maharshi Dayananda University, Rohtak, Haryana. Also, I would like to share the happiness that she secured first rank in the Haryana Public Service Commission examination for the selection of lecturer in applied sciences in the Department of Technical Education, Haryana. I express my sincere gratitude and thanks to Ms. Kajal Sachdeva for joining with us. And dear participants, I am very sure that today's session will be really beneficial to all of you in your preparations. Welcome everyone to this program. Welcome Kajal.
Thank you so much, sir. So, first of all, I would say thanks to you, sir, as you have given me again opportunity and sharing my knowledge with very dear students. So, directly we will start with our lecture. Today, we are going to learn about first order ordinary differential equation. The basic on the ordinary differential equation was already delivered by Miss Unnati Shukla, and you can see her lecture. And basically, today we are going to cover first order, first degree ordinary differential equation and its solution. So, a journal first order, first degree differential equation is of the form dy by dx is equal to fxy. It means the function of x and y, where dy by dx is at the left hand side. We can separate a equation like this, or it can be of the form m dx plus n dy is equal to 0, where m is any function of x and y and n is any function of x and y. These two equations are equivalent, like we can separate this equation like this, minus n dy. Now dividing by dx, we get minus m by n this side, and here dy by dx. So this is a function of xy whole. So we can get the equation like this. So the journal first order first degree equation can be of the form this or of the form this. After that, we have the equation can be of 4 further types in first order first degree: separable equation, homogeneous equation, exact equation, linear equation. In the coming, we will learn about these 4 types of equation one by one and find the solution on these. So first of all, we have separable equation, a equation in which we can separate this as a function product of two functions. One is the function of x and other is function of y. It means like this, we have some 3x square, y square. So it is separable in x and y. If we have like x plus y ka square, this cannot be separate in x and y differently. So if we can separate the right hand side as a product of two functions, where one function is of x and another function of y, then this type of equation is known as separable equation. Then we can write this equation as function of x into function of y, and after that we can separate it like this, taking y one side and x another side. Then now the whole left hand side depend on only y only, and the right hand side depend on x only. So we can integrate it and get the required solution. So we have an example on this. Let's try this. Here we have differential equation dy by dx is equal to y. Now from here we can see that we can separate this equation as we have only function of y. So getting y to the right hand side and taking x part to the right hand side and y to the left hand side. Now we can integrate this plus some constant. So here we get The integration of 1 by y is log y, and the integration of dx is x plus c. This is our required solution. So when we have an equation of separable type, we can solve in this manner. Let's try one more example. So we have another question. X minus 4 y raised to power 4 dx minus x cube y square minus 3 into dy is equal to 0. So in this we can see, we can write this equation in the form dy by dx is equal to some another function. So let's take this part to the right hand side, x cube y square minus 3 dy. Now we have dy upon dx is equal to, this dx come this side and the remaining part to the left hand side, y square minus 3 into x cube. We can see from here x minus 4 upon x cube and y4 upon y square minus 3 is equal to dy by dx. Now this equation is separable. Here we have fxy as this, and it can be separate as the function of x into function of y. Now we can separate the variables as this is a separable equation, taking the y as one side. So y square minus 3 upon y raised to power 4, this will come this side, and with dx x minus 4 upon x cube into dx. Now we can integrate them as whole depend on y and this whole depend on x. So taking y raised to power 4 in the denominator to the each, integrate, and similarly here dividing by x cube dx, integrate. So from here we can see 1 upon y square. The integration of 1 upon y square and minus integration of 3 upon y raised to power 4 dy. In the similar manner, 1 upon x square integration minus integration 4 upon x cube dx. Now we can integrate it easily and get the required solution plus some constant c. So in this manner, we can solve this very easily. Let's move to ask to the next. The second type of equation is homogeneous equation. So before understanding what is homogeneous equation, let's get to the homogeneous function. A function is said to be homogeneous of degree n in x and y if we can decide this: f tx ty is equal to t raised to power n f xy. So verify this for given function. If it satisfied this relation, then we can say it is a homogeneous function of degree n. So for this, we can see here, if I put tx ty in this, we get here tx whole square minus 2tx into ty minus ty whole square. So after separating this, t square x square minus t square xy minus t square y square. So getting t square common throughout, we get the same given equation. So t square common, we get f xy. So after comparing with it, we got to know the degree of this equation is 2. So this is a homogeneous equation of degree 2. Also, we can check this by only checking its degree. Here the degree is 2. Also here 1 plus 1 is 2, and also here is 2. So this is a homogeneous function. Now after homogeneous function, what is homogeneous differential equation? A differential equation is said to be homogeneous if this both are homogeneous function of x and y of the same degree. The function with dx and with dy both should be homogeneous equation of exactly the same degree. So in this situation, what we can do for finding solution, we just have to put y is equal to v into x. So after putting this y is equal to v into x, we get the another equation which is variable separable form, and then we can solve this equation. So let's take an example based on this. So we have an example, x square minus 3y square dx plus 2xy into dy is equal to 0. From here we can see this is m, compare it with m dx plus n dy is equal to 0. So this is m and this is n. Here m is equal to x square minus 3y square and n is equal to 2xy. Both are of degree 2 and homogeneous function. So these are the homogeneous function of same degree. So we can say that the given equation is homogeneous equation. Now we just have to substitute y is equal to vx in this equation. This is the procedure for getting solution of this equation. So firstly, write this equation in the form dy by dx is equal to fxy. So for this, we can write it as x square minus 3y square into dx is equal to minus 2xy dy. Now we can write it as dy upon dx is equal to x square minus 3y square upon minus 2xy. Now substituting y is equal to vx. For this, we want dy by dx. So differentiating it with respect to x, we get dy by dx is equal to first function as it is, x ka differentiation 1 plus x as it is, and the differentiation of v is dv by dx. So substituting this here, we get v plus x dv by dx is equal to x square minus 3. Y is equal to vx, so this will become v square upon x square, and here y is equal to vx. Now we can see that x square is common from above and for below also. So this will cancel out and we get x dv upon dx is equal to 1 minus 3 v square upon minus 2v, and this v will come here with negative sign minus v. Now we can solve this. We can see from here that this is a separable equation. The function of x will be separated and the v is also separated. So this is a separable kind of equation. So solving further, plus 2v square upon minus 2v, and here x dv upon dx. So we get 1 minus v square upon 2v with negative sign. So we can shift it here, and x dv upon dx. Now we can separate it, taking v to the left hand side and the part of x to the right hand side. Now we can integrate it. From here we can see that the differentiation of denominator is here 2. So directly we get the integration log v square minus 1 is equal to log x, plus we can also choose constant as log c. Just cancelling the log from the both side. So here x into c. Now this is the solution in v and x, but our given equation in y and x. So substituting back, y is equal to vx. So from here we put v is equal to y by x. So y square by x square minus 1 is equal to xc. And further solving, y square minus x square upon x square is equal to xc. And it gives x square is equal to x cube c. This is our required solution. This is the solution of given equation. So when we have equation of separable kind, we can solve in this manner. So here we have the equation of separable type. So we just substitute y is equal to vx and then get the required solution. Now the next type of equation we can have exact differential equation. A first order differential equation is said to be exact if this condition satisfied. This is the necessary and sufficient condition for the equation to be exact. Just differentiate this m with respect to y and then partially differentiate n with respect to x. If this become equal, then the equation is exact. Otherwise, we can make this equation exact by multiplying some function. That will be discussed further. So first of all, if the equation is exact, then we can get the solution directly, which will be equal to just integrate m with respect to x, keeping y constant, and integrate n into dy, taking the term in n only that terms which are free from x is equal to some constant c. So we can have an example of that exact type of equation. So let's try an example on based on this. So we have an example 3x square plus 4xy into dx plus 2x square plus 2y into dy is equal to 0. So from here, compare this equation with m dx plus n dy is equal to 0. We get m, some function of xy, is equal to 3x square plus 4xy, and n is equal to 2x square plus 2y. This is n. So first check, is this equation is exact or not? So checking curly m upon curly y, that is equal to 4x, and from here curly n upon curl x, which is equal to also 4x. So both are equal. It means the given equation is exact. So in case of exact equation, we can find the solution directly. We can find the solution. We have the equation 3x square plus 4xy dx plus 2x square plus 2y dy is equal to 0. As this equation is exact, so the solution is m dx, keeping y constant, plus the term in n not containing x. So here we have x, so don't take this, only take this part, 2y dy is equal to some constant c. So this is the solution of our required equation. Now we can solve it. With respect to x, we have integrate 3x cubed by 3 plus 4x square y upon 2 plus from here 2y square upon 2, integrate just with respect to y, is equal to c. So we get the required solution, x cubed plus 2x square y plus y square is equal to c. So this is our required solution. Now, if the given equation is not exact, then what will we do? In this case, we will take an integrating factor. The integrating factor is what? If there is some function by which we multiply the whole equation and the given equation become exact. So that will be called as integrating factor. Like if we have this equation, say y dx minus x dy. Let's try this. Y dx minus x dy is equal to 0. In this, we have m is equal to y, m dx, and n is equal to minus x. If we differentiate it with respect to y, we get 1. And if we differentiate it with respect to it, we get minus 1. But in this situation, we can see that this is not equal. So the given equation is not exact. Now, we have to find that some function by which we multiply this equation and this equation become exact. So let's try. Here we have 1 upon xy. Let's try with this 1 upon xy. Is this integrating factor or not? So when we multiply given equation by 1 upon xy, we get 1 by x dx minus also this 1 upon xy 1 by y dy is equal to 0. Now we can clearly see from here, if we differentiate this with respect to y, we get 0. If differentiate this with respect to x, we also get 0, which is equal. So now the equation becomes exact. And we can find the solution in similar manner. Also, we can solve this given equation by another method too. This equation is separable. So for one equation, we can have many methods for solution. This is only the one of the methods. You can use any of the methods which we are discussing today, one by one. Just see their case, and when we should apply this method, this all depends on you. So here we can see that this is the integrating factor. This is also the integrating factor. When we multiply this equation by 1 upon x square, so this become y upon x square minus 1 by x dy. Here dx is equal to 0. So differentiate this with respect to y, we get 1 upon x square. Differentiate this with respect to x, we also get 1 upon x square. This is also exact. For the given equation, we can have many integrating factors. Not only one, but we have many integrating factors. If 1 upon xy is integrating factor, then k upon xy is also integrating factor, where k belong to any complex number, or even real mein baat, even we are talking in real, so k belongs to any real number. So if we get one integrating factor, we can get infinite number of integrating factor. So let's try some special cases when we have the equation is not exact and we want the integrating factor, and you observe that if curl n upon curl y minus curl n upon curl x upon n, this will give you some function of x, then in this situation you can say the integrating factor is equal to e raised to the power integrating gx dx. The trick for this is, we know that for exactness, curl m upon curl y is equal to curl n upon curl x. But if this is not equal, then just subtracting them, taking this one in the denominator and getting this function. So this is just a trick for memorize. You can also see another way, but one of the ways is this: curl m upon curl y minus curl n upon curl x, this n in the denominator, and if you get the function of x, then the integrating factor is e raised to power gx dx. On the other way, we can have another rule also, when this minus this, curl n upon curl x, you can write this as curl n upon curl x minus curl m upon curl y, and dividing by m, this m, and if we get function of y, this function of y, then e raised to power function of y dy is the required integrating factor. So in both situations, let's have some question based on this. So we have a question: x square plus y square plus x into dx plus xy dy is equal to 0. Compare it with m dx plus n dy is equal to 0. We have mxy is equal to x square plus y square plus x, and n is equal to xy. Just differentiate this with respect to y, and differentiate this with respect to x, we have y. Here we can observe that this equation is not exact, because curl m by curl y is not equal to curl n upon curl x. Now in this situation, we can see that if we're taking difference of these two, and obviously if dividing by this, not by this, because this will not give you any conclusion, but if you divide by this, so we want to divide by n, we have rule. What rule? Curl m upon curl y minus curl n upon curl x. Now taking n in the division, and if we get a function of x, then we can have integrating factor also. So from here we can see that 2y minus y upon the n is xy. This will give you 2y minus y equal to y upon xy 1 upon x. So we get some function of x. Now we can find integrating factor as e raised to power 1 upon x integration dx. So from here, the integration of 1 upon x is log x, and with exponential logarithm cancel and we get x. So x is the required integrating factor. So just multiply the given equation by x and it will become exact. So multiply given equation by x The given equation is x square plus y square plus x dx plus xy into dy is equal to 0. Multiply this whole equation by x. We get x cube plus y square x plus x square dx plus x square y dy is equal to 0. So now we can see that from here, integrating m with respect to y, we get 2yx, and integrating this with respect to x, we get 2xy. Now this become exact. Now we have the standard formula for finding solution. Just integrating this with respect to x, taking y constant, plus the term not containing x. But here we have the term containing x. So we have no term here is equal to c. Now just integrate this with respect to x. We get x4 upon 4 plus y square x square upon 2 plus x cube upon 3 is equal to constant. So this is our required solution for the given equation. So here we can see that if the equation is not exact, then we can make it exact by just finding integrating factor. And this integrating factor, by just see what can be the integrating factor. So we have the 4 rules for getting integrating factor. So first rule has been discussed. Now we have a question on second rule. So let's take an example. 3x square y4 plus 2xy dx plus 2x cube y cube minus x square dy is equal to 0. Compare it with m. Dx plus n dy is equal to 0. We get m is equal to this and n is equal to 2x cube y cube minus x square. Now differentiating this with respect to y, we get 12x square y cube plus 2x, and differentiating this with respect to x, we get 3 to the 6 x square y cube minus 2x. From here, we can see that this can be subtracted. Not equal, that means it is not exact. So we are to find some integrating factor. And after observing this, if we subtract and dividing by this, maybe we get some function of y. Let's just try. Curly n upon curl x minus curl m upon curl y is equal to, this will be equal to this minus this 6x square y cube minus 2x minus 12x square y cube minus 2x, this minus this, and dividing by just m. So m is 3x square y4 plus 2xy. So here we get minus 6x square y cube, 6 minus 12, and minus 4x upon. We can take common from here x, y, 3x y cube plus 2. And also from the numerator, we can get common minus 2x. We get 3x y cube plus 2. And dividing by x, y, 3x y cube plus 2. This is cancel out. And from x is cancel out. We get minus 2 upon y, which is only the function of y. So now we can find integrating factor. We want the function of y, which we get. Now the integrating factor is, to make this equation exact, the required integrating factor, integration minus 2 upon y dy. This will be equal to minus 2 log y, which is equal to e log y raised to power minus 2, and which is equal to y raised to power minus 2. So this is the required integrating factor. Just multiply the whole equation by this and the equation will become exact, and you can find the solution in the similar manner. So the multiply y minus 2 by the given equation. Here we have the equation as this. The equation is 3 x square y4 plus 2xy dx plus 2x cube y cube minus x square dy is equal to 0. So multiply this equation throughout by y raised to power minus 2. We get 3x square y square plus 2xy minus 1 dx plus 2x cube y minus x square y minus 2 dy is equal to 0. Now you can check that from here curly m by curly y is equal to curl n by curl x, and this equation become exact. With respect to y, we get 6x square y, and from here also with respect to x, 6x square y. In the similar manner, with respect to y, minus 1 2x y minus 2, and this with respect to x minus plus 2x square y. Okay, so this is equal and the given equation is become exact. Now proceeding in the same manner for getting solution, just integrating this m with respect to x, 3x square y square plus 2x y inverse with respect to x plus term not containing x. In this both we have the term of x, so nothing here. This will be equal to c. Integrating this with respect to x, we get x cube upon 3, 3 to 3 cancel out, plus x square upon y is equal to c. So this is our required solution. So this question is based on the one of the type of integrating factor. Now,
minus x missing, ma'am.
yes, any doubt?
Minus x missing, ma'am.
Minus x, where? This is
Integrate
right.
the constant minus 1.
We have here c, and integrating this with respect to x, keeping y constant. So we get 3x cube upon 3. So from 3 cancel out, we get x cube y square plus. From here integrating with respect to x, x square upon 2. From 2 to 2 cancel, and we get x square. Y inverse will be written upon y is equal to c. Now we can multiply this whole by y also. Y cube plus x square is equal to c into y. So this is the required solution. Any doubt till now?
No, ma'am.
Sorry, ma'am. I think it's minus 1. Sorry, ma'am. It's y inverse. I think it's minus 1.
No, this is y inverse. Y inverse.
Sorry, ma'am. Sorry, ma'am. Sorry, ma'am.
Okay. So proceeding further. Now, the rule number 3 is if the given differential equation is homogeneous. So in this situation, one way is substituting y is equal to vx, and another way is getting integrating factor and then make it exact and get the solution. So for finding integrating factor in this situation, we find 1 upon mx plus ny. So this will be the required integrating factor in case when we have differential equation of type homogeneous. So let's try an example based on this. So we have a question, x square y dx minus x cube plus y cube dy is equal to 0. Compare it with m dx plus n dy is equal to 0. Here m is equal to x square y and n is equal to minus x cube plus y cube. So differentiating m with respect to y and differentiating n with respect to x, we get minus 3x square. Here we can see that this equation is not exact as this is not equal to this. So this is a non-exact equation. So again, we have to find an integrating factor. So in this situation, we can have also the rule number 1. When we subtract these two and dividing by this, we get the function of y. And we can have one integrating factor. But here we want to try a rule number 3, which is on homogeneous type. From here we can see this degree is 3. Also this have degree 3. So this is a homogeneous function of same degree 3. So let's have another rule number 3rd. In this rule, we have integrating factor is equal to 1 upon mx plus ny, if this is not equal to 0. So let's find mx plus ny. So m is x square y and n is minus x cube plus y cube. So getting mx. One second. Mx plus n. So x cube y, m into x, minus n into y, x cube y minus y raised to power 4. This will be cancelled out and we get integrating factor as minus y raised to power 4 below and above 1. So this is a required integrating factor in this situation. Minus 1 upon y raised to power 4. So multiplying the given equation by this and then solve, we get the required answer. So the given equation is as x square y dx plus minus x cube plus y cube dy is equal to 0. Just multiplying by this, minus 1 upon y raised to power 4. So minus 1 upon y raised to power 4 gives minus x square by y cube minus 1 upon y raised to power 4 plus 1 upon y dy is equal to 0. So from here, now we can check this equation become exact. Differentiate this with respect to y, we get 3x square y square, and differentiate this with respect to x, 3x square y. So same, we get this equation exact, and now we can find the solution in this manner. Integrate this with respect to x, keeping y constant, plus the term not containing x. This term, integrate 1 upon y dy is equal to constant. So just solve this equation, keeping y constant, minus x cube by 3 y cube plus log y is equal to c. This is our required solution. We can also deal this problem by rule number 1. So it's depend on you what rule you are applying. The both rule can be applied in this question. Now the rule number 4th is, if the equation of the form this, some function of xy into y dx plus another function of xy into x dy. If we separate dx with y power 1 and the remaining part is whole function of xy, and with dy x raised to power 1 and the remaining part is some another function of xy. So in this situation, we can have integrating factor of the form 1 upon mx minus ny, provided that mx minus ny is not equal to 0. So let's have a question on this rule. So we have a question, 1 plus xy into y dx plus 1 minus xy into x dy is equal to 0. Here we have m dx plus n dy is equal to 0, where m is equal to 1 plus xy into y and n is equal to 1 minus xy x. This is equal to y plus xy square, and this will be equal to x minus x square y. Just check is this equation is exact. So finding curly m upon curly y, 1 plus 2xy, and from here curl n upon curl x, 1 upon 1 minus 2xy. So this is not equal. That means this equation is not exact. But we can see from here that this is the equation of type 4. The rule number 4 can be applied here, y raised to power 1 into dx and function of xy. This is also function of xy, here x raised to power 1 into dy. So from here, we have integrating factor in this type is equal to 1 upon mx minus ny. So getting mx minus ny, 1 upon mx. So when we multiply m by x minus n by y, so we get this, and from here taking xy common, 1 plus xy minus 1 plus xy, 1 to 1 cancel, and we get 1 upon 2 times of xy into xy. So 2x square y square. So this is the required integrating factor. Now multiplying given equation by this integrating factor and then finding solution. So the given equation is 1 plus xy into y dx plus 1 minus xy into x dy is equal to 0. Multiplying this equation by this integrating factor throughout, we get 1 upon 2x square y, because this y will come here, and by dividing this we get 1 upon 2x square y plus xy square, dividing by this 1 upon 2x into dx plus similarly dividing this whole by this, we get 1 upon 2x y square minus 1 upon 2y dy is equal to 0. Now we can check that this equation become exact. Just derivating this with respect to y, we get minus 1 upon 2x square y square, and this with respect to x, we get minus 1 upon 2x square y square. So this equation is now exact, and now we can get the solution as plus 1 upon 2x dx, keeping y constant, plus the term not containing x. So this is the term which do not have the x plus dy is equal to 0, is equal to c, some constant c, as we are integrating it. So from here, now we can just integrate it with respect to x, this one side. So when we integrate this with respect to x, we get minus 2 plus 1, that is minus 1. So minus 1 upon 2xy plus this with respect to x, 1 by 2 log x minus 1 by 2 log y is equal to c. So from here, taking 2 as common, we get minus 1 by xy plus also log x minus log y. This will be equal to log x by y, and this equal to 2c. So this is our required solution. Or you can turn it another form, which is the given in option. Just this is the required solution. Let's move to the another rule. So these 4 rules can be applied when the equation is not exact, and we can make the given equation exact. If the equation is linear first order equation, the linear first order equation is of the form when we have some function of x into dy by dx plus some function of x into y raised to power 1 only is equal to bx. Or we can write this equation in the form dy by dx plus dividing throughout by a1x, a0 plus a1y is equal to bx by a1x. So this can be written as y dash plus py is equal to q, where p and q are some function of x. So if you see any equation of this type, where p and q are some function of x, so this is the equation of linear first order equation in y. This is linear in y equation. Similarly, we can write linear in x equation. Just change y by x and x by y. So in this case, we can find the solution in this manner. Just write the equation in standard form. Then we can have integrating factor by this expression e raised to power integrating px dx, and then we can multiply this whole equation by mu x and then integrate as in the usual manner. Or you can directly get the solution like this: y into integrating factor is equal to integrating factor into this qx plus some constant c dx. So this can also the final solution, because we are just multiplying by integrating factor and then integrating. So this is the same way we can also write the solution directly in this manner. So let's try a question on this. So we have a question. Solve dy by dx plus 2x plus 1 upon x y is equal to e raised to power minus 2x. In this question, we can see that compare it with standard form dy by dx py is equal to q, where p is some function of x and q is some function of x. So this is whole depend on p and this is q. So the given equation is linear in y. So from here we can get integrating factor will be equal to e raised to power integration p dx. So p is 2x plus 1 upon x dx. This is the required integrating factor. Just integrate this 2 plus 1 by x dx. And from here we can have integration of 2 is 2x and integration of 1 by x is log x. So separating this e raised to power log x, which is equal to e to log cancel, and we get x into e raised to power 2x. So this is the required integrating factor. Now we can have solution in this case like this. Y into integrating factor is equal to integrating factor into q. So we have the value of q as e raised to power minus 2x dx plus some constant c. So this is the required solution. Just integrate this. This will be cancelled out by this x square by 2 plus c. Now we can taking y at the left hand side and dividing by throughout by this. We get dividing by x e raised to power 2x. So x e raised to power minus 2x by 2 plus c dividing by x e raised to power minus 2x. So this is the required solution of given equation. So this all types and the solution we have discussed for first order first degree differential equation. So for today's lecture we covered first order first degree lecture, and in the future lecture we can cover the higher degree for the first order differential equation. So let's try some question based on these some previous year questions. So before that, if anyone have any doubt till now, you can ask. So okay, start with some previous year questions that from IIT JAM 2022. So the question says, for some real number c with c lying between 0 to 1, let phi be a function from 1 minus c to 1 plus c to 0 to infinity. This is the domain and this is codomain for the function phi. And this is a differentiable function such that phi 1 is equal to 1 and y is equal to phi x is the solution of given differential equation. Here we have given a differential equation and the solution is y is equal to phi x. And there is some condition on phi also, phi 1 is equal to 1. And we are to tell which one of the 4 is true. So from here we can see that we are discussing on solution, as the solution is phi x and all the 4 equations have the phi x. So let's try to find solution of this equation, and the solution will be equal to phi x. Then we can compare the solution with these 4 equations. So we have the given equation as this: x square plus y square dx minus 4xy dy is equal to 0. So from here we can see that the given equation is homogeneous, as this is the function of degree 2 and this is also the function of degree 2. So these both are homogeneous function of degree 2, and we can write this as in standard form first, then substitute y is equal to vx as we have discussed in theory part. So let's try by this method. Just take 4xy to the right hand side. Now dy upon dx will be equal to 4xy upon x square plus y square. Dy upon dx, sorry, this will become in numerator and this will become in denominator. As dy, this will come here and dx will come here. Dy upon dx is equal to x square plus y square upon 4xy. Now we can see from here that when we substitute y is equal to vx and substituting dy by dx is equal to v plus x dv by dx, we get v plus x dv by dx is equal to, from here, x square plus v square x square upon 4x into Vx. So cancelling x square here, 1 plus V square, and from below 4V. And taking this V to the right in subtraction, we get this. Solving for V, 4V common, minus 4V square. This will give you 1 minus 3V square upon 4V. And from here, x dV by dx. Now this equation is of separable type, taking V to the one side and taking x to the another side. So taking V part to the this side, minus 3V square. And from here, dx upon x. Now this equation is separable and we can integrate to the both side plus some constant c. Here we can see that if we have differentiation of this above, then we can directly integrate it by taking log. So just make the differentiation of this in the numerator. How we can make it? We want minus 6v. So multiplying it by minus 6 and dividing by minus 6 into v. Just we have adjusted the above term by multiplying by minus 6, taking 4 to the common and dividing by minus 6, and below is minus 1 minus 3 v square dv. So this is just a simple criteria. Otherwise, you can substitute v square to t and then simplify as you like. So we get minus 2 upon 3 from here. And this is the differentiation of this. So directly log 1 minus 3v square, which will be equal to log x plus c. We can also use log c as a constant. This on our hand because we have log in all the cases. So taking log here also. This is a constant. Now this will comes in power log 1 minus 3v square raised to the power minus 2 by 3. And this log x into c. Log a plus log b is equal to log a into b. So cancelling log on both sides and substituting v is equal to, as y is equal to vx, so v is equal to y by x. So substituting v is equal to y by x. Minus 2 by 3 is equal to xc. So this is the required solution, but what we have given for equation, we have 4 options in phi. So just use y is equal to phi x and phi 1 is equal to 1. Using both these two, we can remove constant also and replace y by phi x, as we want here phi x. And the equation is sorted. Here square. This is linear side. It means we have to remove this fraction and also substitute y is equal to phi x. And also for removing constant, substitute phi 1 is equal to 1. So firstly substituting y is equal to phi x. And also separating this x square minus 3y square upon x square. Here we can take raised to the power minus 2 this side, multiplying by 3 this side. So 3 also this side, x cube c cube. Taking this 1 by 3 to this side, x cube c cube. Also for cancelling negative, we can just reciprocal this x square upon x square minus 3y square whole square and x cube c cube. Okay. As phi 1 is equal to 1, so when we put x is equal to 1, y is also become 1. This is representing this. Phi 1 is equal to 1 means y at 1 is equal to 1. So when x is equal to 1, y is equal to 1. So substituting this, firstly we can cancel here x raised to power 4, here x raised to power cube. So from cube to 4 cancel and remaining x. So x is equal to x square minus 3y square whole square into c cube. Here we get this. Now substituting y1 at x is equal to 1. Using this, we get x1 minus 3y1 whole square into c cube. So from here we get 2 square 4 into c cube. So we get the value of c cube as 1 upon 4. So value of c cube is 1 upon 4. Substituting here, c cube is equal to 1 upon 4. So this is the required solution. We can write this as c cube is equal to 1 upon 4 gives you 4x is equal to x square minus 3y square whole square. And after substituting y is equal to 5x, x square minus 3 5x ka whole square and the whole square. So from here we get as one of the option. Just taking minus common from here, there will be no effect as minus 1 whole square is plus 1. So the option number second matches with this. We can see from here, the option number second is here 4x, which we want. This cancel out, this cancel out. And here we get minus sign, which we want. So the option number B is correct. Remaining 3 are wrong and the option number B is correct. So just this is a very simple question based on the type of homogeneous equation. Let's move to the next question. This question is from also IIT JAM 2022 and this is a numerical answer type question. You can see from here what the question says. Let yx be the solution of given differential equation. This with some initial condition y0 is equal to 4 and you have to find yx with limiting x tend to infinity. So from here we can see that the given equation is of the type linear in y, as we can compare it with plus py is equal to q, where p is function of x and q is also function of x. So we can directly have integrating factor in this case e raised to power integration p dx, which will be equal to 3x square dx, which is equal to e raised to power x cube. So we can see this is the integrating factor and directly write the solution as this y into integrating factor integration integrating factor into q dx plus c. So just applying this, y into e raised to power x cube is equal to integration e raised to power x cube into q that is x square dx plus c. Now we can see from here x cube and here x square. So we can substitute x cube at t as t. We get 3x square dx is equal to dt. So x square dx is equal to dt upon 3. So just substituting this e raised to power t into x square dx as dt upon 3 and integrating it plus c. So we get integration of et is et upon 3 plus c y into e raised to power x cube. Substituting back t as x cube, we get e raised to power x cube upon 3 plus c y into e raised to power x cube. So we have y is equal to, just dividing throughout by e raised to power x cube, we get e raised to power minus x cube. Now we have the initial condition given, which is equal to y0 is equal to 4. So substituting this initial condition, then approaching limit to infinity. Y0 is equal to 4. Substituting this, it means x is equal to 0, then y is equal to 4. So y is equal to 4, then x is equal to 0. So we get 4 minus 1 by 3 is equal to c, which is equal to, c is equal to 11 by 3. C is equal to 11 by 3. So substituting back 3, we get y as 1 upon 3 plus 11 upon 3 e raised to power minus x cube. So from here, when we taking limit x tend to infinity, also to this limit x tend to infinity, 1 by 3 is constant plus 11 by 3 e raised to power minus infinity, which is 0. So we get 1 by 3 as answer, which is equal to 0.33. So this question comes under numerical answer type. So we have to write the answer up to 2 decimal places, which is equal to 0.33. So any doubt till now?
No,
So
ma'am.
taking another question, which is from IIT JAM 2020 question paper. This is also of numerical answer type. And in this question, quite different question from the previous one, but the given equation is linear in Y. The given equation is of same type, linear equation in Y, but here we have some condition on fx. Fx is not exactly given, but we have some condition. So here the condition is limit x tend to infinity, fx is equal to 1. And we are to find limit x tend to infinity yx. So in this question, as we are to write exactly a numerical answer, we can assume any function fx which satisfied this condition, because we have a function which are satisfying this condition. So taking as simple as possible, we can take fx as simple a function 1, constant function 1, which is depend on x. We can say it as x raised to power 0. So we are taking as simple as function fx is equal to 1, because if a constant function is given, limit value has no effect and it will give you answer exactly equal to 1. You can take any another function also like this, e raised to power minus. This type of function can also be taken 1 minus e raised to power minus x, because this will give you also same answer. X tend to infinity, then we get minus infinity, that is 0, we get answer 1. So either take this, or taking any other function which will satisfy this condition. But because we have limited time in paper, so take as simple as. So we have the simplest function, a constant function, which is equal to 1. So just replacing fx by 1 and then get what the question want. Just replacing fx by 1, we get dy by dx plus tan y is equal to 1. So in this situation, this is a linear equation in y. Just finding integrating factor, e raised to power integration tan dx, we get e raised to power 10x as an integrating factor. Now the solution is y into integrating factor is equal to integrating factor into q, that is 1 dx plus c. So this will give you e raised to power 10x upon 10 integration of e 10x plus c. Dividing it by 1 upon 10 plus e raised to power minus 10x. Now you are to just apply y raised to power infinity for getting the required answer. So we get 1 upon 10. This will become 0. So this will give you the answer 0.1. So this is a very simple question. Just the trick behind this question is taking fx as a continuous function and approaching limit should be equal to 1. You can take any continuous function which have approaching limit this equal to 1. So this is a one way to solve this question by using the differential equation that is linear in y. You can have any another way also, like this is the equation of separable type. We can also taking 1 minus 10y, then separate dy upon 1 minus 10y is equal to dx. You can solve in this manner also. You can also use asymptote method here. The students whose calculus portion is strong, just think this question by using asymptote method. This on you on now. Okay. So let's try some another question. A question from IIT JAM 2019. So this question based on integrating factor. Here, integrating factor is given xhyk. It means some function x raised to power some and plus into y raised to power some k. This is the integrating factor of given differential equation. And you are to find the value of h and k. Like this is h, this is k, or this can be h and k, this can be h and k, this can be h and k. So what we can do, if this is integrating factor, just multiply the given equation by this integrating factor and make the equation exact. If this is integrating factor, then after multiplying this, equation should become exact. So let's try this. Multiply given equation by xhyk. The given equation is y 1 plus xy dx plus x into 1 minus xy dy is equal to 0. So let's multiplying this xh y k plus 1 firstly plus x y square from here x plus h and y k plus 2 dx plus now multiplying this by x h y k we get x h plus 1 y k and here minus x square and from outer h y raised to power 1 and from outer k y plus 1 dy is equal to 0. Now this equation should be exact because this is an integrating factor. So if we here take m is equal to xh yk plus 1 plus x plus 1 yk plus 2 and n is xh plus 1 yk minus xh plus 2 yk plus 1. So if this is exact equation, then curly m upon curly y should equal to curly n upon curl x. So from here, if we differentiate this with respect to y, we get k plus 1 xh yk plus with respect to y k plus 2 xh plus 1 yk plus 1 with respect to y. This is equal to with respect to x. Differentiate this with respect to x, we get s plus h x h y k minus h plus 2 x h plus 1 y k plus 1. Now these two equations will be equal if the like terms are equal. This equal to this equal to 6. So taking their constant also equal, we get k plus 1 is equal to h plus 1 and k plus 2 is equal to minus h plus 2. Like term should be equal. So from here we can see k is equal to h and substituting this here k is equal to h minus 2 we get 2h is equal to minus 4 h is equal to minus 2. As k is equal to h, so k is also equal to minus 2. So both k and h are equal and which is equal to minus 2. So option number first is correct, minus 2 and minus 2. So this is just a very simple question, multiplying it by integrating factor and make it exact. Let's try one more question from previous year, from 2018. So here, this is a multi-select answer type question. We can have one solution, two solution, three solution, or can be the all four solutions. Just check all the four options. So we have to find the solution or solutions of the differential equation this with satisfying y0 is equal to 0. So here we have a differential equation sine 2x into y raised to power 1 upon 3 given y0 is equal to 0. So first of all, the option number 1 is y is equal to 0. See, if this is solution, then it should be satisfy the given equation. So y is equal to 0, give this side 0. Y is equal to 0, also give this side 0. So this satisfy the given equation. Also, this is satisfying the condition also. So both the equation and condition also satisfy. So this is the solution. Because this is satisfying the given equation. So this is the solution. Now check from B, C, D, which is the solution. One way is just substituting this in given equation and check is this satisfying or not. If it, then this is the solution, otherwise not. But here we can see that the given equation is of separable type. The whole function depend on x and this whole depend on y. So just separating the variables, we get dy upon y raised to power 1 by 3 and sine 2x into dx. Integrating both sides plus c. We get y raised to power minus 1 by 3 plus 1, that is y 2 by 3 division, and this will be equal to minus cos 2x upon 2 plus c. So from here we get 3 y 2 by 3 equal to minus cos 2x plus 2c. 2 is numerator. From both sides we can cancel and here multiplying by 2. Now the given condition is y0 is equal to 0. Substituting this 0 minus 1 plus 2c. So we get the value of c as 1 by 2. The value of c is 1 by 2 or 2c is equal to 1, we can say. So in place of 2c, just substitute 1. We get 3 y raised to power 2 by 3 is equal to 1 minus cos 2x. Now from options, we can see that we have option either sine cube x, cos cube x. So we can see from here, we don't want multiple angle 2x. We want the angle only x. So we know the formula, cos 2x is equal to either 2 cos square x minus 1 or 1 upon 1 minus 2 sine square x. Here we can see that we want 1 minus cos 2x. So for 1 minus cos 2x, we have to use the second formula. So 1 minus cos 2x is equal to 2 sine square x. So substituting this, 2 sine square x, and here 3 y 2 by 3. Now y 2 by 3 is equal to 2 upon 3 sine square x. Now from here we can see that taking cube both side. So when we take cube both side, we get 8 upon 27 sine cube x whole square. We can write this as either 6 or taking cube in and then 2 in the whole power. So we get from here taking square root. When we take square root, the plus minus sign both come sine cube x whole square. From square we can cancel square root and the root will come only on 8 upon 27 sine cube x. So this is the solution. Another two solutions even, one from plus and one from minus, under root 8 by 27 sine cube x. And also you can see that y is equal to 0 is lost in this case. The solution y is equal to 0 is lost because we are integrating this, and for integrating this we are supposing y is not equal to 0. So for y is equal to 0 we have to check and find this. This is a solution which cannot be obtained by this type separable, but can be found by just substituting and checking. And some another way, in the basic lectures we have already discussed this, and these two solutions can be found by separable kind, which we have seen. So option A, B, C are correct, and the option D can cancel out in the starting, like y0 is equal to 0. Here y0 is equal to under root 8 by 27 as cos 0 is equal to 1. So this is not satisfying the condition. So we can directly cancel out this D option without solving even. So the option A can be simply satisfying. So this is the solution. B and C is finding by this procedure, and D can be cancelled out in this manner. Y0 is not equal to 0 in this case. So the required answers are A, B, and C. So let's take some another question. This question is from IIT JAM 2017. In this question, we can see we have the solution yx of this given differential equation, which are satisfying y0 is equal to 1, and we are to find y at -1. So in this case, we can see that the given equation of the form m dx plus n dy is equal to 0, where m is equal to xy plus y plus e raised to power minus x, and n is equal to x plus e raised to power minus x. From here, we can check, is this equation exact or not? Curl m upon curl y is equal to x plus 1, and curl n upon curl x is equal to 1 minus e raised to power minus x. So this is not equal. So the given equation is not exact. But we can see from here that if we subtract these two, we get somewhat like this. So dividing by this, we have function of x or function of y. Let's try. So we are subtracting curl n by curl x because we want in denominator n. So taking n this side, and if we get function of x, then we can write integrating factor directly. So curl m upon curl y is x plus 1 minus 1 minus e raised to power minus x, and dividing by x plus e raised to power minus x. From here we can see x plus 1 minus 1 plus e raised to power minus x upon x plus e raised to power minus x. From 1 to 1 cancel out. We get numerator and denominator exactly same. We get 1, which can be say as function of x. We want function of x. This is x raised to power 0, we can say. So in this situation, we have integrating factor, which is equal to e raised to power integration fx dx. So e raised to power integration 1 dx, which is equal to e raised to power x. So we have integrating factor e raised to power x. After multiplying the given equation by e raised to power x and then substituting y0 is equal to 1, we get the value of constant. And after that, just substitute y at minus 1. We get the required solution from one of these. So multiplying given equation by e raised to power x, as e raised to power x is the integrating factor. So multiplying by e raised to power x, y plus 1. Also from here, x e raised to power x plus 1 dy is equal to 0. Here we can now check this is an exact equation, as curl m by curl y is equal to x e raised to power x plus ex. And from here, x e raised to power plus ex, which is equal. So this equation is exact. So what we can do, just integrate this, keeping y constant. And from here, taking only the term which not containing x. So cancelling this, just integrate with respect to y, and this will be equal to some constant c. So integrating with respect to x. For integrating this with respect to x, we have to take u into v rule, apply u into v rule, and taking this function as first and this as second. So taking x constant e raised to power x integration minus x differentiation 1 and e raised to power x integration e raised to power x into y plus e raised to power x into y as e raised to power x, keeping y as constant, plus x, 1 integration is x, plus here from 1 integration is y is equal to c. So from here we get x ex minus exy plus e raised to power xy plus x plus y is equal to c. This will be cancelled out. We get this as required solution. Now substituting y0 is equal to 1. So we are substituting y0 is equal to 1 here. We have at last the solution as e raised to power x into xy plus x plus y is equal to c. We have this. Now substituting y0 is equal to 1, x as 0, 0, x 0, y 1. So we get c is equal to minus 1. Ex, xy plus x plus y is equal to c. Yes. So from here we get x is equal to 0 and then this and this. Okay. So using c is equal to minus 1, we get ex, xy plus x plus y is equal to minus 1. So this is a required solution, but we have to find the value at y minus 1. This the question want. So substituting x is equal to minus 1. E minus 1 into y, x minus 1 plus 1 is equal to minus 1. So this will be cancelled out, and taking this common, y 1 minus e minus 1 is equal to, I think here some we have missed some thing in behind. Yeah, we have x e raised to power x into y plus x plus y is equal to c. And we have y0 is equal to 1. So substituting y0 is equal to 1 here, 0, y0 plus 1 is equal to c. So c is equal to minus 1. So from here, when we substitute this, we get the solution as this. Y is equal to 1 upon, and after solving this, you can check this is a standard procedure. Maybe we are getting some option problem. So if this is the correct, so option D is correct. If we have done not any mistake, maybe there will be some calculation mistake, as here we get 0 and so y is equal to 0. But y is equal to 0 is not the possible solution because y0 is equal to 1 is given. So I don't think so y is equal to 0. So here we have getting any calculation mistake. You can check it later, but the procedure is the same. Here we have the procedure mdx plus ndy, and then using to make it exact, we have used this, which is absolutely correct. And after that, this is also correct. Maybe there is some mistake in multiplying by integrating factor and then integration, then integrating it. So we have cancel out and we get x into exy plus y is equal to c. This is correct. But when we are substituting y0 is equal to 1, maybe here can be any problem, because after substituting y0 is equal to 1, c should be equal to 1. There is some problem. Okay, so let's try this after class. Let's move to another question. The question from JAM 2016. Here, the question says one of the points which lie on the solution curve of the differential equation. This is a given differential equation, and with given initial condition, we have to tell the solution will lie on one of these points. So we have to check. First, we have to find solution and also eliminate C by using this condition. After that, substituting these points, which will satisfy the given equation, that point will lie on that solution curve. We know that if we have given some curve and if some point lying on that curve, then it will definitely satisfy this equation. So we have to at last check if this point lie on solution curve. So this point should satisfy that solution. Also, if this, then this point will satisfy the solution. So firstly, we have to find solution. There is no another way. We have to find solution. From here, we can see the given equation is of the form mdx plus ndy is equal to 0. And we can compare given equation by m and n. So one way is that. And another way can be, this is the homogeneous equation of degree 1 each. So we can also apply y is equal to vx. So in any way, you can solve this question, but we are taking this as mdx plus ndy is equal to 0, where m is equal to y minus n, n is equal to x plus y. So firstly, check is the given equation is exact. Curl m upon curl y is 1 and curl n upon curl x is also 1. So this is a very plus point here, that given equation is exact. Now we can directly write the solution of this equation. Just integrate this with respect to x, keeping y constant, plus term not containing x, that is y is equal to c. So from here we get, keeping y constant, we get y into x minus x square upon 2 plus y square upon 2 is equal to c. So we get from here yx minus x square by 2 plus y square by 2 is equal to c. Now using initial condition, we have initial condition as y0 is equal to 1. So substituting y0 is equal to 1, at x is equal to 0, y is equal to 1. At x is equal to 0, y is equal to 1. So we get c is equal to 1 by 2. So substituting c is equal to 1 by 2, or we can take 2 as common from both denominators. We get this. So this is the required solution. 2yx minus x square plus y square is equal to 1. This is the solution curve. Now we want to check is which of the following point lie on solution curve. So first point is 1 minus 2. Let's check 1 minus 2. 1 minus 2 means this is x, this is y. So taking x as 1 and y as minus 2, we get minus 4, x as 1, y as minus 2, we get minus 1, which is not equal to right hand side. So this point do not lie on solution curve. So option first cancel out. Similarly, we check option number second, 2 minus 1. So checking 2 minus 1, is it satisfying the solution? Just substitute this here, minus 4, and taking y as minus 1, so plus 1. Here is 2 minus 1, minus 4, and here minus 2 square, that is 4 plus 1. So this is also not solution because it is giving you minus 7, which is not equal to 1. We want 1. So this is not solution. Check third one, 2, 1. Is 2, 1 lying on solution curve? So 2, 1 checking. Substitute x as 1 and y as 2, x at 1, x at 2, sorry, x as 2 and y as 1, y as 1. Yeah, this is satisfying the given solution. So this is the right answer, 2, 1. Similarly, you can check fourth one will be cancelled out. So option A, B, D are wrong and the option C is true. Option C is correct. So this is a very simple question as this is exact equation. Now let's try one more question from the previous year. This question, we have differential equation of the form this: sin 2x dy by dx is equal to 2y plus 2 cos x. Now you can think from here, this equation can be written in the form m dx plus n dy also. Or also depend on you. You can also write this equation as linear in y, because here 2y raised to power 1, which will give you dividing by sin 2x. Here also sin 2x dividing by. So this will treat as q, 2 cos x upon sin 2x, and this will be treated as p, minus 2 upon sin 2x. So both way are correct, which you like, either linear in y or m dx plus n dy form, then check is it exact or not, then use any another way. So we have both choices here. Let's try m dx plus n dy, because you can solve in linear in y equation very easily. Let's try by another method, that is m dx plus n dy. Sin 2x dy is equal to 2y plus 2 cos x into dx. So writing it as 2y plus 2 cos x dx minus sin 2x dy is equal to 0. So now this is in the form m dx plus n dy is equal to 0. Now we can compare it with where m is equal to 2y plus 2 cos x and n is equal to minus sin 2x. Now differentiating m with respect to y for checking exactness here 2, and here with respect to x we get minus 2 cos 2x. Now from here we can see that the given equation is not homogeneous. We can see directly. Also, this equation is not of the form function of xy y dx minus plus function of some another xy x dx. So rule number 3rd and 4th cannot be applied. Now check either rule number 1 or rule number 2 can be applied to make it exact. Can we find integrating factor from here? So we can see here, if we subtracting these two and dividing either by m or by n, we get some function of x or some function of y or not. Let's try that way. So if we subtracting curl m by curl y upon curl n by curl x, we get 2 plus 2 cos x, and dividing by n minus sin 2x. So from here we can write 2 1 plus cos 2x upon minus 2 sin x cos x, as we know that sin 2x is 2 sin x cos x, and 1 plus cos 2x can be written, cos 2x is equal to 2 cos square x minus 1. So 1 plus cos 2x is 2 cos square x, 2 cos square x upon minus 2 sin x cos x. From 1 cos x to cos x cancel, 2 to 2 cancel, we get minus 2 upon sin x, which is equal to minus 2, and from above cos x, 1 cos x and 1 sin x. So cos upon sin is cot x. So this is the only function of x which we want. Here the x is given. So now we can find integrating factor easily. In this case, integrating factor e raised to power minus 2 cot x dx. So just to differentiate minus 2 cot x with integrate with respect to x, we know that the integration of cot x is log sin x. So sin x raised to power minus 2 is the required integrating factor, or you can write it as 1 upon sin square x, or you can write cosecant square x. So this is the integrating factor, cosecant square x. So multiplying by this and make the given equation exact. So we have the given equation 2y plus 2 cos x, multiplying it by cosecant square x dx minus here sin 2x multiplying by cosecant square x dy is equal to 0. Now you can check this equation is exact. Now you can check easily. This equation is definitely exact. Just derivative this with respect to y and derivating this with respect to x, and take this equal to, we get exact equation. Now for finding solution, we just have to integrate this, keeping y constant dx. And from here, term not containing x. Here both the term containing x, so we are not taking this, and equal to some constant c. So just integrating this with respect to x, we know that cosecant square x, integration of cosecant square x is minus cot x plus. From here, integrating this to, here what is given? 2 cos x, cosecant square x. We can write this as 1 upon sine square x, and taking one sine to here, that is cot x, and one sine we can write cosecant x. And we know the integration of this. So just we have shifting one cosecant square x to this, and one cosecant square x here is equal to some constant c. So we have just simply integrate this. We know that 2 cot x cosecant x dx integration is minus 2 cosecant x minus 2 cosecant x is equal to c. So from here, we have also given some condition y pi by 4 is equal to 1 minus root 2. We have condition y pi by 4 is equal to 1 minus root 2. So substituting this, cot pi by 4 is equal to 1 into y. Y what is 1 minus root 2, okay, minus 2 cosecant pi by 4. So cosecant pi by 4 is equal to 1 upon sine pi by 4, and we know that 1 upon sine pi by 4 is 1 by root 2. So reciprocal is root 2. 2 root 2 is here, is equal to c. So we get the value of c as minus 2 plus 2 root 2 minus 2 root 2 is equal to c. So c is equal to minus 2. So substituting c as minus 2 and taking minus 2 common, we get y cot x plus cosecant x is equal to 1. And we can write, because we are to find y, 1 minus cosecant x, and y is equal to 1 minus cosecant x upon cot x. We can also simplify this. Cosecant x is 1 by sine x, and cot x is cos x upon sine x. So taking denominator sine x as common out, we get sine x minus 1 upon cos x. So this is the required solution. But in the given question, we are to check the given solution is bounded or unbounded. When x tend to 0, x tend to pi by 2. So let's try x tend to 0. When we apply limit x tend to 0 on y, limit x tend to 0, sine 0 is 0, cos 0 is 1. So we're getting finite answer, which says the solution is bounded. So at x is equal to 0, solution is bounded. Also try at x is equal to pi by 2, x tend to pi by 2, we get x tend to pi by 2. If we apply x tend to pi by 2, sine pi by 2 is 1, 1 minus 1, 0, and also cos pi by 2 is 0. So we get 0 by 0 form. In this situation, we apply L'Hopital rule. So taking differentiation of above and differentiation of below separately. So sin x differentiation is cos x, and cos x differentiation is minus sin x. We get, applying cos pi by 2 minus sin pi by 4. Sorry, हम pi by 4 पे check करना. We are to find pi by 4. In given question, we have pi by 2. Okay, pi by 2. Check on pi by 2. Okay, pi by 2, pi by 2. So cos pi by 2 minus sin pi by 2. We know that cos pi by 2 is 0 and sin pi by 2 is 1. So we get 0, which is again a bounded, a finite answer, a bounded answer. So in both the situation, we get the solution is bounded. So the option number C and D is correct, and A and B are incorrect. So the correct option is C and D. So this is the required answer, and this all the question based on our today's lecture. And today's lecture we have learned about first order, first degree solutions, in which we have basically the 4 kind of solutions 4 type of even equations, in which we have studied linear equation in y, in x you can try simultaneously. Also we have checked the case of homogeneous equation, and also separable type, exact type equation. If not exact, then how we can apply integrating factor and find that, and then find solution. So these all techniques can be applied when we have a equation, a linear equation, either first order degree and first order first degree equation, in case of both type of equation. And these are the books which you can study for this. Mainly we have 3 books which I follow. The important one book is Differential Equation by S.L. Rose. So this will clear your theory based on this topic. And we have lots of problem in this book, M.D. Rai Singhania, a book by M.D. Rai Singhania, Ordinary and Partial Differential Equation. And also you can clear your doubts from this equation, this book, and Introduction to Ordinary Differential Equation by Congington. So thank you for your time and attention. And now you can ask if you have any question, any queries are welcome.
Hello, ma'am. My name's Alina Anna Matthews. I'm currently a third year student, BSc. So, ma'am, thank you for such a wonderful class. You explained each and every questions, and also you took the topic very well. Thank you, ma'am.
Thank you. Thank you so much.
Hello, ma'am. I'm Gayatri. I have done my graduation from Miranda House College, Delhi. It's really great that you have covered a lot of important points within the time limit, and the class was really amazing. It was worth attending your class, ma'am. Thank you so much.
Hello, ma'am. My name is Aparna. I am a graduate student from Kerala. Ma'am, today's class was very wonderful, and I understood everything, like every step by step. There was no, I never got any, your explanations were clear. And so, ma'am, thank you so much for giving your time for this. Thank you, ma'am.
Thank you, Aparna.
I'm Nandana Jevarma from Zamorians Guruyarpan College. And thank you, ma'am, for this wonderful section and for this informative section. And thank you, sir, for organizing this. And thank you so much, ma'am.
Thank you, Vandana. Thank you so much.
Hi, ma'am. Am I audible? Ma'am, my
Yeah.
name is Iritty. I'm
Hello.
finally a BSc mathematics student, and I think today's class was really helpful for me. And also I think tomorrow we are having a practice test on ordinary differential equations. So this class was really helpful for us. And you have discussed every questions in a very detailed way. You have explained the reasons also throughout the session while you are discussing each and every step. So it was really helpful for me, ma'am. I didn't get any kind of doubt in this session because you have explained everything in a detailed way. And yeah, thank you so much, ma'am.
Thank you so much.
I am Kiki from NIT Trichy, and I am a MSc second year student. Ma'am, today's session was really very helpful for us because as you know that next month is our GATE exam, and we are preparing for it. And by your lecture, it is very helpful, and we have to we understand the concept once more time for our practice. So thank you so much, ma'am, for your time and for this wonderful session. Thank you so much, sir, for arranging this session.
Yes.
I am Dharmendra Singh from BRC Vijay, and I am really from Agra, Kasganj. This session is very nice, and every problem is very understandable, and it is very interesting topic also. And I think it is easy all of other topic also. Thanks, ma'am. Thank you, sir.
Thank you, Dharmendra.
Maria Joseph from Assumption College, Kerala. Actually, ma'am, your class was really nice. It will truly help us in preparing for our JAM exam. And the concepts you clear will really help us for brushing up our studying process. And thank you, Vinod sir, for always bringing us the best. Thank you.
Thank you so much.
Thank you, Maria.
Hello, ma'am.
Yes,
I'm Anjana from Central College, Ernakulam. I'm a final year BSc Math student. First of all, thank you, ma'am, for this amazing session.
All the problems discussed today were explained very well, and it also helped to refresh the concepts of differential equation. Thank you so much, ma'am, for your valuable time and efforts, and thank you, Vinod sir, for organizing this session for us.
I'm Hiba, a first year MSc Mathematics student from IIT Palakkad. So it was a very nice session, ma'am. You have explained everything from the very beginning, and it was too good. And you have explained many previous year problems. And thank you, ma'am, for this full session. Thank you, sir, for arranging this. Thank you.
Hello, ma'am. I'm Gopika from Zamorian Guriappan College, Kerala. Today's session is really nice. You explained each and every question really well, and this will help us for our preparation. Thank you so much, ma'am, for your time and effort, and thank you so much, Vinod sir, for conducting this session.
Yes.
I am Shikha from Birla Institute of Technology, Mishra, Jharkhand. I'm second year MSc student, and ma'am, your session was really nice. Due to some network issue, I won't be able to attend your session till the end. So sorry for that. And whatever I have listened and heard, it was really nice, ma'am. Thank you, ma'am, for your time. Thank you, sir.
Yeah.
Thank
Thank you.
you.
Hi, ma'am. I'm Amal. I'm from Iritty Mahatma Gandhi College. Ma'am, the session was so nice. It was very helpful for brush upping all the previous knowledge on OD, and the nice collection of problems were also helpful. Thank you, ma'am, for the valuable time.
Thank you.
Hello, ma'am. I'm Malavika, third year BSc Math student of Aspirants Guriappan College, Kerala. Thank you, ma'am, for this wonderful session. The class is really nice and it is very helpful for us. Thank you, ma'am, for sharing your valuable time with us. Thank you so much, ma'am. And also, I would like to thank Vinod sir for conducting such a wonderful session for us. Thank you, ma'am and sir.
Thank you, Gopika.